Okay, we're going to talk about a very special function called the greatest integer function. And the greatest integer function could be written with the words int in front of the x, or it could be written with those hard brackets on both sides of the x. Textbooks will use both versions of them. And the greatest integer function is really asking you to look for the largest integer value that is less than or equal to the input value. So, for example, if I wanted to know what the greatest integer of 2 was, well, the greatest integer that is equal to or less than 2 is the number 2. If I wanted to know the greatest integer of 2.1, well, the greatest integer less than or equal to that value is still 2. The same if I asked you to find the greatest integer of 2.9, it would still be 2, or 2.99999. The greatest integer less than or equal to that number is 2. But as soon as I try to find the greatest integer for 3, I jump up to 3. So the picture also jumps up. I have this little grid over here, and if I look at a value of 2, at 2 my value is a y value of 2. At 2.1 it's still a y value of 2. At 2.9 it's still a y value of 2. I can get really close to 3. I can have an open circle there, and it will still be very close to 2. But as soon as I hit 3, it goes up, and the pattern continues. So in each case, I'm going to get a closed circle on the left-hand part and an open circle on the right-hand part. And we call this a step function or the greatest integer function. The domain of this function is all real numbers. I can pick anything I want to, no problem. But the range is really weird. The range is only integer values. I'm never going to have a y number that's not a whole positive or negative integer value. Okay, be very careful when you're drawing a greatest integer function. The left-hand side of each step is a closed circle. You're including that point. The right hand of each is an open circle. You're not including it because that's the point at which the function jumps. So this is not a continuous function. It doesn't smoothly go from one piece to the other. Although the domain is continuous because as I jump to the next value, I actually have a value for that x. So the domain is all real numbers.